Here we're being given an infinite series, the sum from n equals 0 to infinity of 3 raised to the n plus 2 power divided by 2 to the n. And what we're going to be trying to determine for this series is if it converges, which means it adds up to a finite number, or diverges, which means that it doesn't. Now there should be some key indicators for every one of these series that hints at what test might be best to use. And the first thing I'll say is oftentimes there's more than one right way to approach these problems. You have these list of convergence tests, and sometimes 2 or 3 or even 4 of the convergence tests might all be applicable. But for this one in particular, I see some key indicators that hint that one of those tests might be the easiest to use. All right, one thing I noticed right off the bat is that the index starts at 0 instead of 1. A lot of times when you see that, these will be geometric series. Now, does every series that start with 0 have to be geometric? Certainly not. But that's kind of an indicator right off the bat. Second of all, is the details aren't exactly perfect, but it looks like we have powers of n, which would also seemingly indicate possibly a geometric series test, because I have these n's in the exponents. Now, it's not the same power, which is a little bit of a problem, but it might be worth exploring a little bit. Okay, so this is my vote. I think geometric series is probably the way to go because it almost looks like our format for a geometric series. Now, I will say, just as a side note, if you said like ratio test, you could probably still work this one out fine with the ratio test, as well as some of the other tests that I won't go through the whole list. But for me, I think I'm going to work this one with the geometric series test. Okay, so my initial goal is to make this guy look literally like him. So one thing I need is right off the bat is I need somebody with a power of n, not 2 terms but 1 term. Now I think I can get these guys to have the same power of n if I pull out a few single factors of 3, because this is 3 raised to the n plus 2. I have 2 factors too many. So why don't I try this? This is a common technique. We'll take the sum n equals 0 to infinity. I'll pull 2 factors of 3 out, which will be 3 to the second times 3 to the n divided by 2 to the nth power. Now notice this is perfectly legal. This is fine, because what is 3 to the 2 times 3 to the n? It would be 3 to the 2 plus n, or n plus 2. And so these are certainly the same, but you see now why I wanted to do that. I wanted to pull those extra 2 factors out so that these 2 terms right here can be combined into my r to the n. Alright, so let's rewrite this one more time. So we'd have the sum n equals 0 to infinity. We'd have 3 squared is 9. And then we would have 3 halves to the nth power. Right? Awesome. We did good. This is typically what you're going to have to do, is manipulate the terms in your series to make it look like a p-series or an alternating series or a geometric series, or whatever test you're wanting to use. You're usually going to have to manipulate the terms around. They're not just going to hand it to you on a silver platter. All right, but now it looks like a times r to the n, so I'm ready to give my answer. I'll ask you, what do you know about geometric series? These guys converge when, and they diverge when? Well, they converge when the r is between plus or minus 1, like a small decimal, and they'll diverge if the r is bigger than 1 or less than negative 1. So I look at my r value. My r value is 1.5, is 3 halves. So this series right here, right, this guy, he is going to diverge, right? This guy is going to diverge, but don't just say diverge. You also have to say this as well. Diverges by the geometric series test. And if you don't mind my abbreviation, I'll just shorten that up a little bit so I don't have to write it all out. But this guy diverges by the geometric series test. So you have to say if it converges or diverges, as well as what test you use to show that.